Good evening, everyone. We are here to discuss the week 4 assignments, some sample problems. We will just wait for a few minutes for others to join. So let it start. Am I audible? Good evening, everyone. Myself, Prasad Anjali Ramashankar Chanda Devi. I am PMRF from IIT ISM Dhanbad. Today we are going to discuss some assignment problems of week 4 NPTEL course NOC23-ma11 numerical methods finite difference approach. So here is our first question. So first question is, for the first order one-dimensional hyperbolic equation del u over del t plus c into del u over del x is equals 0, x greater than 0, comma t greater than 0, what will be the correct representation of the order of the error in the Venn graph scheme? So options are: first, order of del t plus order of del x square; second, order of del t square plus order of del x; third, order of del t square plus order of del x square; fourth, order of del t square plus order of del x cube. So according to Venn graph scheme, find the order of the error. So here the one-dimensional hyperbolic equation is this given to us. Del u over del t plus c into del u over del x equals 0. So first you will be applying forward difference over here and forward difference for here. Apply and put r is equals to del t upon del x. See what you are getting. So you will get ui comma j plus 1 is equals ui comma j minus cr by 2 into ui plus 1 comma j minus ui minus 1 comma j. Now u xi comma tj plus 1 can be written as u xi comma tj plus del t into del u over del t plus dot dot dot. So after solving this, you will get del u by del t as u of xi comma tj plus 1 minus del t by 2 del square u by del t square. not this. U of xi comma tj whole divided by del t. Now substituting this over this previous equation and here applying central difference, you will get the answer. So answer is C, order of del t square plus order of del x square. Just verify it with your calculations. Let's move to the next question. Second question is, the explicit scheme for solving hyperbolic equation del square u over del t square equals del square u over del x square plus u with del u over del t equals g of x at x equals to 0 is. So you have to solve this you have to expand this hyperbolic equation by explicit scheme, and you have given one boundary condition del u over del t equals g of x at x equals to 0. So apply the explicit scheme on this and see what you are getting. As a hint, you have to calculate for j equals to 0. Proceed forward. So this is our question. This was our question, the explicit scheme for solving hyperbolic equation. So when you will apply the explicit scheme on this term and this term with this boundary condition, find out what of this you are getting. So you will get answer A, ui comma 1 is equals to r square by 2 into ui minus 1 comma 0 plus ui plus 1 comma 0 plus 1 minus r square plus half times del t whole square into ui comma 0 plus del t times gi. Fine. Now here is our third question. The first order one-dimensional hyperbolic equation del u over del t plus del u over del x is equals 0, where x lies in between 0 to 2.0 and t lies in between 0 to 1.0 with boundary condition u of x comma 0 equals x and u of 0 comma t equals t. Fine. So this is our one-dimensional hyperbolic equation, and these are our boundary conditions. So by using Lax-Wendroff's method and assuming del x equals del x that is h equals 0.10 and del t that is equals to k is equals 0.10. So you have to find the value of u of 1, 2. And your options are, after solving, see what you are getting: a as 0.2 or b 0.1, c 0.25 or d equals 0.15. So just apply over here Lax-Wendroff's method and see what you are getting. So by applying Lax-Wendroff's method, you will get uj of n plus 1 equals ujn minus half uj plus 1n plus uj minus 1n plus half ujn plus 1 minus 2ujn plus uj minus 1n. Fine. Now we have been given the boundary condition as u0 comma t equals t. So using that, what we'll get, that implies at a point at mesh point k, that is u0 comma k, the value will be k. Fine. So apply this on this equation. What you'll get, uj1 is equals uj0 minus half uj plus 1 0 minus uj minus 1 0 plus half uj plus 1 0 minus 2 uj 0 plus uj minus 1 0. Fine. So uj1 will be equals to j minus 1 into h. Solve this. Are you getting this? So you will get uj1 is equals j minus 1 into h. Calculating above relation, what you will get? u11 equals 0, u21 equals h, u31 equals 2h. Putting n equals to 1, we will obtain u12 is equals, just substitute here and in this formula, so you will get u12 equals h is equals to 0.1. Fine. So our answer is B, 0.1. Just try to solve it and verify your answer with the steps. I hope you are getting this, as b is equals to 0.1. So let's move to the next question. So our fourth question is, suppose that the partial differential equation del u over del t minus del square u over del x square is equals to 0 is approximated at the point I comma j by the finite difference equation theta of ui comma j plus 1 minus ui comma j minus 1 upon 2 del t plus 1 minus theta of ui comma j minus ui comma j minus 1 upon del t minus 1 over del x square of into ui plus 1 comma j minus 2 ui comma j plus ui minus 1 comma j is equals to 0. Then you need to find what will be the truncation error at this point. Fine. So your options are A, minus del t upon 2 into 1 minus theta minus del x square over 12 whole into del square u upon del x square at I comma j plus you get a truncation error of order del t square plus order del x square, or B as minus del t by 2 into theta minus del x square over 12 whole into del raised to power 4 u upon del x 4 at I comma j plus truncation or error as order del t square plus order del x power 4, or C as minus del t by 2 into 1 minus theta minus del x square by 12 into del 4u upon del x 4 at I comma j plus order of del t square plus order of del x power 4, and D as minus del x square by 12 into del x to power 4u upon del x 4 at I comma j plus order of del x power 4. So on this PDE, approximate this at this point using finite difference equation and see what will be the truncation error. Fine. So basically you have to do what? Just apply the Taylor series expansions and see what you are getting. Just apply over here for each term ui comma j plus 1 ui comma j minus 1. Apply the Taylor series expansions, the respective Taylor series expansions, and eliminate the higher order terms and arrange in these equations and simplify it. So I hope you will be getting answer as C. Let's see how. As you know, the Taylor series expansion of ui comma j plus 1 is equals ui comma j plus, as it is increment in j, so you will be having del t into del u over del t at I comma j plus del t square by 2 factorial So we are having Taylor series expansion of ui comma j plus 1 as equal to ui comma j plus del t into del u by del t at I comma j plus del t square over 2 factorial into del square u by del t square. Why so? Because there is increment in j. Similarly, ui comma j minus 1 will be, as there is, we are going one step back, so minus del t into del u over del t at I comma j plus del t square by 2 factorial del square u by del t square at I comma j. Similarly, ui plus 1 comma j will be ui comma j plus del x at into del u by del x at I comma j plus del x square by 2 factorial into del square u by del x square at I comma j. So substitute these values in these equations and eliminate this higher order terms. See what you are getting. Similarly, substitute ui minus 1 comma j is equals to ui comma j minus del x into del u over del x at I comma j plus del x square by 2 factorial into del square u by del x square at I comma j minus del x cube by 3 factorial into del cube u by del x cube at I comma j plus dot dot dot. Fine. Now when you will substitute these values in the given truncation error equation, so you will get theta into ui comma j plus 1 minus ui comma j minus 1 upon 2 delta t plus 1 minus theta into this was the equation you had been given, so 1 minus theta into ui comma j minus ui comma j minus 1 upon del t minus 1 upon del x square into ui plus 1 comma j minus 2 ui comma j plus ui minus 1 comma j. So substitute all the Taylor series expansions. So when you will substitute over here, you will get 2 del t into del u over del t at I comma j plus 2 del t q upon 3 factorial into del cube u upon del t cube at I comma j plus dot 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 upon 2 del t. Similarly, substitute in these equations and see, are you getting this? Just verify till this step. So this will be equal to, now simplify it, so see what you are getting, theta into del u over del t at I comma j plus 1 minus theta into del u by del t at I comma j minus del t by 2 factorial into del square u by del t square. We are simply, like here 2 del t by 2 del t gets cancelled and we have removed the higher order terms. Here also del t over del t gets cancelled and removing the higher order terms, like from 3. So del u by del t at I comma j minus del t by 2 factorial into del square u by del t square at I comma j minus, similarly here what you will get, here del x square by del x square will cancel out, so you will get del square u by del x square I comma j plus del x square by 12 into del to the power 4u upon del x to the power 4 at I comma j plus order of del t square plus order of del x to the power 4. Fine. See, are you getting that? Now from this you will get del u by del t minus del square u by del x square, this term minus this term and the remaining terms, plus 1 minus theta into this whole minus del x square by 12 into this term. Fine. Plus order del t square plus order of del x to the power 4. Fine. So after solving, we are going to get del u by del t minus del square u by del x square at I comma j plus minus del t by 2 into 1 minus theta minus del x square by 12 into del 4u upon del x4 at I comma j plus order of del t square plus order of del x to the power 4, which is option C. Fine. I hope you are getting it. Take some time and see, are you getting it? Fine. So hope you are getting to this as option C. Let's move to the next question. So here is our question number 5 that says for C equals to 0.5, R equals to 0.5. So both the values C and R are 0.5. The Lax-Van scheme for solving one-dimensional hyperbolic equation. So one-dimensional hyperbolic equation is given as del u by del t plus C del u over del x is equal to 0. X is greater than 0 and t is greater than 0. So you have to find the Lax-Van scheme out of this which satisfies this equation at given C equals 0.5 and R equals 0.5. So your options are A, ui comma j plus 1 is equals to 1 upon 16 into 15 uij plus ui minus 1 comma j minus 5 ui plus 1 comma j. B is ui comma j plus 1 is equal to 1 upon 32 into 3 ui comma j plus 5 ui minus 1 comma j minus 3 ui plus 1 comma j. C is ui comma j plus 1 is equals 1 upon 16 into 30 ui comma j plus 5 ui minus 1 comma j minus 3 ui plus 1 comma j. D is ui comma j plus 1 is equals to 30 ui comma j plus 5 ui minus 1 comma j minus 3 ui plus 1 comma j. So apply the Lax-Van scheme's formula at given C and R. See what you are getting. So Lax van 't Hoff scheme is ui comma j plus 1 is equals to 1 minus c square r square into ui comma j plus half cr into 1 plus cr into ui minus 1 comma j minus half cr into 1 minus cr into ui plus 1 comma j by replacing. Now this is the Lax van 't Hoff scheme. Just replace the value of c equals 0.5 and r equals 0.5. So what will be c into r? That is half into half is equals to 1 by 4. Just substitute the value of cr in this equation and see, are you getting this as ui comma j plus 1 is equals to 15 by 16 ui comma j plus 5 by 32 ui minus 1 comma j minus 3 by 32 into ui plus 1 comma j. Fine. So option C will be correct. Just verify your steps and solve it properly. See, you are getting C. So you will get the option as C. ui comma j plus 1 is equals to 1 by 32 into 30 ui comma j plus 5 ui minus 1 comma j minus 3 ui plus 1 comma j. Here it should be correction, it should be 32. Now let's move to the next question. So here is question number 6. Consider the hyperbolic equation root x into del u over del x plus u into del u over del y is equals to minus u square, and the condition u equals to 1 on y equals to 0. Fine. So this is our hyperbolic equation, and we have been given condition as u equals to 1 when y is equals to 0. When it is so, when x lies in between 0 to infinity. So which among the following is the Cartesian equation of characteristic through r of xr comma 0 where xr is greater than 0? Fine. So your options are a is equals to y equals log of 2 root x plus 1 minus 2 root xr. B is y is equals to log of 2 root x plus 1 minus 2 under root xr minus xr. C is y is equals to log of under root x plus 1 minus under root xr. D is y is equals to log of 2 under root x plus 1 minus 2 under root xr. Solve this hyperbolic equation using characteristics. Then through r xr comma 0, find which of this is the characteristic Cartesian equation. So what you are getting as answer? Solving it here, as you can see, we are having root x into del u over del x plus u into del u over del y equals minus u square. So first, finding characteristics. By characteristic method, you will get dx by under root x is equals to dy by this term is equals to u is equals to du by this term minus u square. Fine. Are you getting this? Now y is equals to what? Just take this first term and second term and this third term and solve. So when you will take u over here, so it will get cancel out and integrate it. See, are you getting y equals to log of 1 by u? So on solving this characteristics, dy by u is equals to du by minus u square. You will get y is equals to log of 1 by u. Fine. Now proceed with the method of finding characteristic equation, Cartesian equation of the characteristic through r of xr comma 0. You will get 1 by u is equals to 2 under root x plus 1 minus 2 under root xr. After getting 1 by u as 2 under root x plus 1 minus 2 under root xr, substitute this value in this. So you will get y equals to log of 2 under root x plus 1 minus 2 under root xr. That is option A. Fine. So the Cartesian equation of this hyperbolic equation is given by A. That is y equals to log of 2 under root x plus 1 minus 2 under root xr. Fine. Now let's move to the next question. Question number 7 is, which of the following is correct when under root x del u over del x plus u into del u over del y equals minus u square, comma, u equals to 1 and y equals to 0 and 0 less than x less than infinity is solved by the method of characteristics up to second order approximation. So it was same as in first in sixth question. Now here we have to find the method of characteristic up to second order approximation. So find which of this will the value of up square. That is, will you get up square as 0.91, 0.84 or 0.97 or 0.70? Solve it using method of characteristics and see what you are getting. Solve it using method of characteristic. The hyperbolic equation is under root x del u by del x plus u into del u by del y equals to minus u square. And condition you have been given as u is equals to 1 on y equals to 0, where x lies from 0 to infinity. So you will get answer as A. Just check it. Are you getting 0.91? So here, as we have been given under root x del u by del x plus u del u by del y is equals to minus u square. So on solving, you will get under root x dy is equals to minus u square dx. Fine. Apply the characteristics. First get to the step as under root x dy is equals to minus u square dx. So this implies what? Under root xr into first up to first order approximation, that is up1 minus 1 is equals to minus ur square dx. Fine. So are you getting this? Check it. So after getting this, that is under root x square xr up1 minus 1 is equals to minus ur square dx. This will imply up1 as 0.9. Fine. So are you getting up1 as 0.9? So after you get UP1 is equals to 0.9, further solving you will get minus half UR square plus UP1 whole square dx is equals to half under root xr plus under root xp into u square p minus ur. That implies u square p is equals to u2p is equals to 0.9117. Fine. So answer will be A. UP2 is equals to 0.91. Just check it. Solve up to second order approximation. Are you getting UP2 as 0.91? I hope you are getting UP square, UP2 is equals to 0.9117. Is there any doubt till here? I hope you have got through all the 7 questions and the hints provided to solve them. May they help you to solve the week 4 assignment. We discussed some problems on Lax-Wendorf's method, and then on the method of characteristics to solve the hyperbolic equations. Here in this previous question 6, it was same. Here just we found the characteristic through r xr comma 0, and in the next question, that is question number 7, we found it up to second order approximation. Fine. Then we discussed some problems on Lax-Wendorf. And here we found a truncation error. Then again, for one-dimensional hyperbolic equation using Lax-Wendorf's method, we found the value of iteration u12. Then we found the explicit scheme of hyperbolic equation where boundary value condition was given. So hope in all this, I'm just summarizing all the questions, like which kind of questions we solved during the session. I hope you have got through it and hints may help you to solve the questions. I'll upload this on YouTube. You can go through it. And try to solve the week 4 assignment problems. And one more thing, whenever there are you have to find the truncation error, and such approximations have been given, so just apply the Taylor series. Taylor series expansion, and you will get through it, like you will get the order of truncation error. Fine. In previous week sessions also we did the same thing. Whenever we have to find the truncation error, so just apply the Taylor series expansions and eliminate the higher order terms. You will get the required truncation error of that. Like here, as we got del order of del t square plus order of del x to the power 4. Fine. So just keep in mind, then whenever you have to find the truncation error, just expand it using the Taylor series expansions, and just use this. Like whenever there is increment in like here it was increment in j. Fine. So j is what? The increment in t, time value. So you will write first uij plus del t into derivative of u with respect to t plus, as the second term of Taylor series expansion is del t square by 2 factorial, and second derivative with respect to of u with respect to t. Similarly, you have to go. Now here it was -1, so the step size, that is del t, will be negative. Here it will be positive as we are taking square. Here it will be negative again. Now here, as it was an increment was in I, so first term will be uij plus del x, as there is increment in I, into del u by del x. Similarly, you will keep on going, and as per your requirement, delete the higher order terms. Basically, most of the time we delete from the 2. And you will get your approximations. And this is the method of solving hyperbolic equation using Cartesian equation. Will be given to you, and you have to find the characteristic. So just find the characteristic, and using the characteristic method you will get the solution. In the next question we did it for second order approximation. Fine. Hope you are clear with all the sessions till now, like week 1, week 2, week 3, week 4. So here we are ending up with the sessions of NOC23-ma11. We have discussed the assignment problems based on week 1, week 2, week 3, and week 4 live sessions. So thank you for being till here and in the doubt clearing sessions. These videos will be of week 1, 2, and 3. I have already uploaded. So week 4 also I will upload, and you can go through the videos. And if you have any doubts, you can post in the discussion forum, or you can comment down. All these 4 videos will help you to go through some sample questions and their solutions or hints to solve those questions. I've tried to give some hints or solutions to them. Using those, you can go through the solution and you can get the answer. These sample questions will help you to solve the assignment questions. Thank you for being here. Just go through all the 4 videos, you will get the sample questions, and in case of any doubts, you can post in the discussion forum. Here we have ended all the sessions, doubt clearing sessions of numerical methods, finite difference approach of this year's, that is NOC23-ma11. Thank you.